welcome to Chill Online. Today we are going to do a little bit of chemistry while making our own ice cream. For this activity, you will need one large Ziploc bag, one small Ziploc bag. You'll need some sugar. I've just got a bag of cane sugar here. I'm also going to use some food coloring in my ice cream because you guys know me, I like things really colorful. The recipe that you see in your bag also calls for some vanilla, but I've got a little bit of peppermint oil that I'm going to add to my ice cream because my favorite ice cream is mint chocolate chip. You will also need some ice, which you can make in an ice cube tray or buy in a big bag at the grocery store. Now, ice, when it melts, is absorbing heat. So you can imagine all the snow outside your house right now that's melting is actually taking in the heat that the environment is providing now that we have a little bit more sunlight. We'll use rock salt in this activity. It's actually not the same thing as the table salt that you have at home. It's much less processed, and so it has larger crystals, but it's also not great to eat because it has some impurities in the processing of it. The reason why we make ice cream with these large crystals of salt is because there's a lot more surface area on them. And this thing is going to take a lot longer to dissolve in a cup of water than just a little bit of table salt. Go ahead and try it. Fill a glass with water, put your salt in there, and see how long it takes to dissolve. Okay, so I have had this rock crystal of salt in my glass of water for about 40 minutes now, and I still haven't seen any sign of it dissolving. Why do you think it is that a larger object with larger surface area will take longer to dissolve than tiny little crystals of the same object? We add salt to lower the freezing point of ice. Ice will melt at 32 degrees Fahrenheit. Molecules of matter in a solid state start to move around when the solid thing is melting. But when salt is added to that mixture, the freezing point actually lowers. Have you ever hiked along the beach in the wintertime and noticed that the seawater doesn't freeze? Well, the ocean water has a lot of salt in it. And in order for that salt water to freeze, the temperature has to get a lot lower than 32 degrees Fahrenheit, which we know is the normal freezing temperature of water. Heat is transferred from the environment, which includes your ice cream mixture, to the ice, making the ice cream mixture a lot colder. You can actually control how fast your ice cream forms by changing the amount of salt that you use. If you're really hungry for ice cream and you want it to happen really fast, would you want to use more salt or less salt? Perhaps with these larger crystals of rock salt, the ice will take even longer to melt and we'll get a smoother ice cream. Let's make some ice cream! Step 1, we will take our small Ziploc baggie and add our 1/2 cup of milk, 1 tablespoon of sugar, and 1/4 teaspoon of vanilla. Make sure to seal that bag really well. And I'm gonna mix mine around since I have food coloring in there. Now we'll take our large Ziploc bag, which will be our outer bag in this experiment, and fill it about halfway with ice. Now I'll take my bag of ice and add my rock salt to it. There should be about 1/2 cup of rock salt in your little baggie already. All right, it's time to make ice cream. We'll take that bag of milk, sugar, and whatever food coloring or peppermint or vanilla you added in there and give it a good mix before making sure that the seal is closed super tight and put it in your bag of ice and salt. I'm gonna close that really tightly as well. So let's shake it up. Okay, I've shaken my bag up for about 5 minutes, and lo and behold, my liquid ice cream has turned into a solid. Remember how your milk molecules fit the shape of the container they were in? i.e. this plastic baggie. Well, now your solid ice cream won't flow to fit its container quite so well. Now is a great time to pause the screen and fill out the vocabulary sheet for solids, liquids, and gases. If it didn't work, if you still just have a cold bag of sugar and delicious whole milk and maybe some vanilla or peppermint, it's delicious. Take a spoon and eat it anyway. I'm gonna try something a little different. I have found some sugar cones in a box. Let's see if my ice cream is still liquid enough to fit the volume of this container. Ah! And there you have it. Chemistry experiment turned delicious dessert. Oh my gosh, it's so cold. Post a picture to the Google Classroom page of you and your ice cream, whether it was solid enough to fit into a cone or not. We'll check in about how your ice cream project worked at our Zoom meeting on Thursday.